ಸರ್ ನಮಸ್ಕಾರ ಸರ್. ಹಲೋ, ಹೇಳಿ ಸರ್. ಹೇಳಿ ಸರ್. ಓಕೆ ಓಕೆ. ಒಂದು ಏನೋ ವಿಡಿಯೋ ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆ ಸರ್, ಆಡಿಯೋ ಮಾತ್ರ ಇದೆ. ಇಟ್ ಇಸ್ ನಾಟ್, ಕ್ಯಾಮ್ರಾ ಇಸ್ ನಾಟ್ ಡಿಸ್ಪ್ಲೇಯಿಂಗ್.
Sir, hello.
Sir, tell me, sir.
Sir, was disabled participant screen sharing like that? It is showing, sir, for me.
Sanath, Mr. Sanath.
Disabled participant screening.
Now you can share, sir. Please go ahead, sir. You can share now.
Okay.
Disable or not? I am putting for recording.
Yeah.
Sir, everything is ready now.
Okay. Time? Another 1 minute. We'll wait just 2-3 minutes. There is a lesser participant. Just wait. Janardhan?
Sir, ಹೇಳಿ ಸರ್.
ಪಾರ್ಟಿಸಿಪೇಟ್ ಒಬ್ಬ ರಿಮೈಂಡ್ ಮಾಡ
ಮಾಡಿದ್ದೀನಿ ಸರ್, ಕಾಲ್ ಮಾಡಿದ್ದೀನಿ ಸರ್. ಈಗ ಎಲ್ಲರೂ ಲಾಗಿನ್ ಆಗ್ತಾ ಇದ್ದಾರೆ ಸರ್.
ಓಕೆ ಓಕೆ
ಓಕೆ ಸರ್.
Within 2-3 minutes we can start, sir. Because we are given YouTube link also for outsiders. So, Director, sir, we can wait or we can start, sir.
Sir, I am ready, sir.
Sir, please, you can start, sir.
Okay, sir.
Others, they will join, sir.
Okay, sir.
Please
Yeah.
start.
Good evening to one and all present here. I'm happy and honored to welcome all the participants and the speaker of the day for this master's training program on construction management and engineering economics. This is the 7th lecture on online, just awareness upskilling program with respect to construction management techniques. And we all know that the previous speaker, Dr. Krishnamurthy sir, clearly mentioned what are the various problems the buildings will encounter distress. One is design errors and construction errors. In the construction, actually, the most widely used material is concrete. The next to water, the highest consumption is only concrete. And it is in the hands of the engineers, civil engineers or construction engineers, how to make good concrete and bad concrete or durable concrete. Where concrete ingredients are same, but making a good concrete or durable concrete is in the hands of all the civil engineers. Therefore, we all know that the fourth ingredient of the concrete is water. Water is a very important ingredient of the concrete. See, the water quality plays very important to make a durable concrete. The durability means it has to perform according to the lifespan designed for the concrete, because otherwise concrete will deteriorate. Even the previous speaker, Krishnamurthy sir, clearly mentioned the deterioration of concrete due to physical action, chemical action, and mechanical action. See, one of the chemical action is due to the salts present in the water. Therefore, before using water for concrete making, we must select a good quality of water. As per the IS 456 clearly mentioned, potable water. The water used must be potable to make a concrete, then only concrete is durable. Now we are unable to get a potable water in many areas of construction, especially where the groundwater is being used. Even some of the constructions in Bangalore going on with the grey water, treated grey water. Therefore, this topic will give lot of inputs to all the engineers, Nirbhiti Kendra engineers and the budding civil engineers. What are the various methods of testing of water and also wastewater? Because in future, the recycle, reuse concept of water, therefore the treated water can be used in your construction. I know that in Kabban Park, 75 MLD water has been treated with a tertiary method. L&T is using in a big way for construction activities. I think Nagappa sir also will agree. Almost rupees 45 to 50 rupees they are charging for 1,000 kiloliter of water. Because I personally visited the plant and inspected. There is a very neatly designed the recycle reuse of water in Kabban Park, and we are not getting any foul smell also. Even I don't know, I myself stunned by seeing the treatment techniques and the ambience of the treatment. Excellent, sir, actually. And therefore, this is the need of the hour for all the engineers to learn how to test water, what are the important qualities of water must be there, especially the sulfates and chlorides. What are the limits are that? Today, I welcome our today's speaker of the day, Dr. B. Nagappa sir, former senior scientific officer. He is going to throw more light on what are the various testing standards and how to check the report of this one. I'm very happy to welcome you, sir, for this online seminar scheduled for Nirbhiti Kendra engineers. On behalf of our center and my own, I welcome you once again, sir.
Thank you, sir.
And also I welcome our Honorable Director, sir, Srinivasa Kulkarni, sir, for this seminar. Welcome you, sir. And also I welcome all the participants of the Nirbhiti Kendra, because these are the lectures scheduled to get the more awareness on this. In future, available water is less. You must interact with the speaker. And at the end of this one, you can share your chat box, all the queries for this. And also welcome all the NCET engineers and also the program coordinator online, Mr. Sarath Kumar, for this online seminar. Before going to the lecture, a brief introduction about Dr. Nagappa sir. Dr. B. Nagappa, former senior scientific officer, is work in the Karnataka State Pollution Control Board. He is having a PhD in chemistry, and he did research in combustion-derived nano metal oxides for environmental applications. And also he has having a vast experience with the help of testing of this water and wastewater as per the standard codes of practice. and also a lot of trainings and professional experience gained by in the area of noise monitoring, networking of the pollution levels, and also air quality assessment and emission inventory and source apportionment studies in Germany, and also visited many countries like Spain, Germany, USA, and learned many things, how to do training aspect, monitoring aspect, testing aspects. And also Nagappa sir is also a professional affiliation with respect to life member of Electrochemical Society of India and also Association of Analytical Society of India. And also I'm happy to share this. He has patented one of his research work, methods of preparing nanocrystalline MgO and zinc oxide products and using same for removal of fluorides and arsenics from contaminated water. See, we are all comes under the Kolar, Chikballapura, a lot of groundwater is fluoride affected. So now there is a solution. Sir is going to share that in the name of Department of Science and Technology, Ministry of Science in the year 2007. And also, sir is having a lot of credits with respect to international publications. He has published 22 papers in reputed journals and also published national journals of 15 papers and also published more papers on national and international conference, more than 25 plus. And also he has addressed invited talks and shared his knowledge almost 200 plus. So we are very happy and we are honored to have you today with your rich experience. All our participant is going to benefit this lecture. It is a need of the hour. All civil engineers must know what type of water we can use. And also I'm happy to share on this occasion, I have guided one project, sir, actually Rushbavati treated water. It is, I don't know what is the level of treatment they did. We conducted a study on properties of concrete using grey water. Finally, our students are able to publish an international publication. This has been made on attempt almost 10 years back. Thank you once again to all of you. I welcome once again. Now I request Dr. B. Nagappa sir to take over the session.
Thank you very much, sir, for brief introduction. And once again, I am going to thank to organization having invited me to talk in this good occasion, because all are construction engineers, majority of them civil engineers, I think.
Yes, sir. Yes, sir. Yeah, yes, sir.
Okay, sir. Very important component in the civil engineering also, water is very important. There are 4 or 5 designated best users. Among best users, construction industry also, they are using a lot of water for the construction purpose. Today I am going to discuss on testing of water and wastewater as per the highest standard. There are several methods they have given. If you take any method, any parameter, nearly 4 to 5 methods are published one, accepted one. But yeah, if you go, laboratory is accredited with NABL or EPA recognition, we have to follow highest standard only as per the NABL guidelines. Apart from this NABL guidelines, a lot of methods are available. We have to standardize the method. Which one is good method? Generally, we used to use 4A theory. 4A means accuracy, acceptability, accountability, and accuracy. 4A thumb rule generally we used to follow any methods. Out of these methods, really Indian methods are very good. Everybody is throughout India, we are following Indian standard methods for testing of water and also wastewater. What is safe water? What do you mean by safe water or good water? Water should be free from pathogens, free from turbidity and color. This is more important. All over throughout the India, our surface water bodies, lakes, rivers is turbid and as well as color. Free from unpleasant taste and smell. It should be free from chemicals that may cause corrosion in the water pipelines or in the construction industry also. If it is containing a lot of sulfate, already the sir has mentioned, chloride and sulfate is 2 culprits. It is going to deteriorate the cement characteristic. It should be free from pollutants from the adverse effect on the human health. It means that safe water throughout India, if you search throughout India, it is not at all available. If you go to Kanyakumari, Kashmir to Kanyakumari, if you go to Brahmaputra river, even Brahmaputra water is contaminated. Ganga, Yamuna, all are contaminated. If you come to South Indian rivers, as well as Karnataka rivers, especially 7 river systems are there in Karnataka. One is Kaveri, Bhima, Tungabhadra, Bhadra, Tungabhadra, like this. All are contaminated with minimum pathogens, color, turbidity is there. And also, there are so many reasons for the pollution of surface water. Ultimately, for any type of pollutants emitting to the atmosphere means ultimate sink is the rivers, reservoirs, lakes. If these things are contaminated means it is going to lead to the borewell also. Even borewells also contaminated. So finally, because of industrialization, urbanization, agricultural, lot of pesticides, herbicides, they are being adding to the land. And fertilizers, more fertilizers also reflecting in the water bodies nowadays. It means that if any good rains, ultimate it is carrying all the agricultural waste as well as pesticides, herbicides, all the insecticides to the water bodies. Final sink is rivers and lakes. From rivers and lakes, it is percolating to the borewells. So borewells also contaminated with pollution. Before understanding the analytical techniques to quantify the pollutants levels, we should understand the aquatic chemistry. What is aquatic chemistry? Do you think water is just H2O formula? It is a complex chemical. A pure water essentially is not existent in the natural environment. In the world, you can test throughout India, pure water is not at all existing. Even natural water also, it is contaminated. If you collect the Brahmaputra water sample, you analyze it for at least pathogens are present. If the pathogens are present, means it is not fit for any consumption. In natural water, whether it is atmosphere or ground or surface or underground water, contains 60 to 70 different kinds of minerals, dissolved minerals, gases as a result of interaction with atmosphere, minerals in the rocks, organic matter and living organisms. Throughout the world, if you collect any water, drink groundwater or surface water, collect, you analyze it, at least 60 to 70 different kinds of minerals are existing, but the concentration of minerals are different. If you see this one, this is one textbook I have referred, same thing I have extracted in 2 slides. It is generally in water bodies, we are classifying into major ions and minor ions. What are the major ions? Major ions means the concentration in the range of 1 to 1000 milligram per liter is called major ions. The concentration in the range of microgram, nanogram, picogram level, it is called minor ions or trace constituents. Generally, trace constituents we are not quantifying because it is a highly expensive technique is required. GC, MS, MS, if you couple 2 techniques, the equipment cost is more than 2 crore. That's why we are not at all analyzing trace metals like nanogram level, picogram level. The metal concentration or any anion or cation concentration in the range of milligram, definitely we are going to quantify all the minerals. In the major ions, we are classifying into 2 groups. One is major cations and another one is major anions. What are the major cations? Sodium, potassium, calcium, magnesium, iron, silica, aluminum, and arsenic. These are the only major cations available in the groundwater or surface water. If you come to the anions, chloride, sulfate, nitrate, fluoride, phosphate. Apart from this one, if you think anything is extra means it is added one because of the man-made activities or due to the pollution, it is going to reach to the water column. If this concentration, what is the ranges of concentration, we have to analyze only by using analytical techniques. We have to quantify this calcium, magnesium means we have to use good analytical technique to quantify the concentration of any cations or any anions or trace metals, heavy metals, whatever it is. We have to use selected, standardized, approved internationally or nationally. Indian highest standard, as per the standard, we have to use the procedures to quantify any element present in the water. Why water quality analysis is required? Water quality analysis is required mainly for the monetary purpose? No. Water quality analysis reports are extremely necessary in the sectors of public health, drinking water purpose, industrial use, aquaculture, agriculture purpose, as well as construction industry also. To check whether the water quality is compliance with the standards are suitable or not suitable for the designated best use means public health sectors, means domestic sector, industrial sector, aquaculture sector, agriculture sector, whether it is for these designated best use, whether the water quality is fit to use it or not. To cross-check that one, we have to do the analysis. To monitor the efficiency of treatment plant working in the water quality maintenance systems and water quality systems, water treatment system, water works, what we are calling in major treatment plants, whether the system is working or not. We have to collect the different sections of the treatment facility. We have to check it, analyze it and check it, whether it is working efficiently or not, or whether it is partially working. What is the efficiency of the treatment plant we can estimate by using the analytical reports only, no other route. To check whether the upgradation or changes in the existing system is required or not. For this one also analytical reports are required. If you see, if you plan it today, another 10 years down the line, if you see that quantity of the wastewater is being doubled or tripled, the existing facility is not capable to take care of all those things. For this purpose, whether we have to do the upgradation or changes, we have to make it. To know that one, very good analytical reports are required. For the national planning and pollution control strategies and their prioritization, good analytical reports are required to evaluate the water quality trend over the period of time. If it is the natural water, but surface water, but in rivers, lakes, every year we have to analyze, we have to collect the samples, we have to quantify that one and evaluate the water quality over the period of 5 years down the line, or 10 years down the line, or previous, what is the today, what is the characteristic of water, we have to assess it. To assess assimilative capacity, water is a great character. Water itself, it is having very good assimilative capacity to treat the water from treat the pollutants in the water body. If it is moves continuously flowing rivers, generally assimilation capacity is very high. It is going to treat itself. If you take Kolar, this one system now, Bangalore, wastewater is being pumped to Kolar lakes. After passing through 30-40 kilometers, automatically it is going to take care of pollutants. Assimilation capacity is increased, is very good in flowing water because a lot of oxygen is going to exchange from the atmosphere to the water column. When the oxygen is supplying to the water bodies means definitely treatment capacity itself, water itself, it is having own treatment capacity that is called assimilative capacity. It is going to, if the assimilative capacity is very high, we can reduce the cost of the pollution control. To monitor whether the water quality in complies with environmental rules and regulation, pollution point of view, for the industry it is applicable. Definitely, this is very important, this one. And also to know all the above reasons, we required very good analytical report. To get a very good analytical report, good laboratory is required. The role of laboratory plays important role in assessing the status of the environment, both biotic and abiotic. Laboratory processing samples taken from the environmental media, both from the environment as well as from the source, disposing into the environment, industries, domestic agriculture sources, automobiles, everything, whatever the discharges, ultimately final sink is the water body. When it rains, it is going to wash it away, then it is reach into the lakes, reservoirs, then rivers. From the lakes, reservoirs, percolating to the bore wells. The laboratories are essential cornerstones of any effective pollution control programs. Means if we have a very good report, very good analytical report, we can plan pollution control programs. The analytical laboratory provide a qualitative as well as quantitative data for the good decision making. This is more important. MOF, Government of India, is making a lot of programs. Treat the Ganga Action Plan if you take it, Yamuna Action Plan if you take it. Because of lack of good analytical reports, Ganga Action Plan, Yamuna Action Plans are not completely fulfilling all the criteria. The generating this valuable data with the desired accuracy, this is more important, and quantitative concentration of pollutants present in the samples, it is more important to take any decision or to make any pollution control programs. The laboratory should have a desired laboratory facilities, very good sophisticated equipment facilities we should have, and also trained staff. I have seen a lot of civil engineering laboratories. Trained staff is not at all available in Karnataka. As per Karnataka is concerned, I have seen all the engineering colleges I have visited, and a lot of private laboratories also visited. Trained staff is required to get a very good data to achieve the above goal. You see the Karnataka scenario of groundwater quality. I have taken one report from Central Groundwater Board One report they have published, the Karnataka report is there. You see, salinity problem is there in the borewell. Now I am coming to the borewell water quality. Bangalore, Belgaum, Bellary, Davangere, Gadag, Gulbarga, Raichur. Salinity is very high. Fluoride is more than 1.5 milligram per liter is there in Bangalore. So many districts, almost all the districts, we are getting fluoride. Because of excess of fluoride, if you consume years together, fluorosis, dental fluorosis, skeletal fluorosis, you can see in Karnataka also. Chloride content, Balkot, Belgaum, Gadag, Dharwad, more than 1000 milligram per liter is there. If you use groundwater having more than 1000 milligram per liter of chloride, definitely your cement quality or concrete quality, definitely it is going to deteriorate. Nitrate, if you take it, 45 milligram is the limit. Almost all the districts having nitrate problem is there in the groundwater. This is the actual report published by Central Groundwater Board. Especially where there is a waterworks are there, water irrigation projects are there, Kaveri Basin, Krishna Basin, like this. They are using, farmers, they are using a lot of nitrate, urea like compounds. Even crop is taking 25%, even soil is taking 25% means remaining 50%, it is washing out. It is directly it is coming to the lakes and reservoirs. Finally, our reservoirs, lakes are enriched with nitrate content. It is some places it is not at all fit for drinking in groundwater. You see, so many districts are there. Almost all the districts. Arsenic problem, Raichur, Gulbarga, and Chitradurga. Arsenic generally associated with the gold ore. Gold, they are extracting it. Arsenic, they are discharge, throwing out as a slag. As a slurry, it is coming out. Then finally, arsenic is dissolving in water. When it rise, it is percolating to the, it is reaching to the water column of the borewell. 3 districts, we noticed arsenic content. This is the dental fluorosis and skeletal fluorosis. Almost all the districts we have fluoride problem, including Bangalore. Arsenic problem, you see. One this is the right foot I have photograph. It is from Chitradurga, I have taken it. One entire family, they have used the borewell water for the drinking purpose, very good water. Salt is less sweet, good water, clear crystal water, but it is having arsenic content. It is near to the Hatti gold mines, Chitradurga. When the gold is there extracting, arsenic they are throwing out, finally it is reaching to the borewells. They are continuously, one entire family legs and foods like this. Then we requested the district authority to give the treatment to this entire family. Then this one photo I have taken, one few photos from Assam, Bihar, like this it is there. Arsenic also highly toxic compound. Nitrate, if the nitrate content is excess in the water, drinking water or in the water bodies, blue baby syndrome, more than 45 milligram per liter is there. If you drink it continuously for 1 hour or 2 hours, newborn baby, they are facing blue baby syndrome. If you can see in Mandya, this photo I have taken from the Mandya hospital photos, this. And the Mysore, even this one, Belgaum, where the irrigation projects are there, that area, they are facing a lot of fluoride problem, blue baby syndrome problem also. Yeah. Now I am coming to the methods of individual parameters. As per the Indian standards, 10,500 for drinking water, and also as per the Pollution Control Board, also Government of India also stipulated parameter for surface water, borewell water, as well as rivers and lakes. We have to do more than 35 parameters. We have to analyze every month. Some parameter they have specified for quarterly. Some parameter they are specified for the seasonally. But throughout the year, we have to do the monitoring. We have to cover. We have to analyze the water samples of surface water, rivers, lakes, and borewells. As per the guidelines issued by the Government of India, and by following IS methods. pH meter. pH is one of the important parameter. The limit is 6.5 to 8.5 pH. If it is less than that one, also problem. It is more than that one, also problem for the construction industry also. So pH we have to measure correctly by using pH meter as followed by IS method. Conductance, conductivity meter, color, spectrophotometric method, odor, afflectometer or electronic nose, nowadays it is available. turbidity, nephroturbidity metric, sulfate turbidity metric or spectrophotometric method, nitrate chromatrophic acid method, alkalinity titration, total dissolved solids gravimetry, total hardness EDTA titration, calcium EDTA titration, magnesium calculation, chloride Argentine titration, fluoride Spans reagent method we are calling, iron spectrophotometric method, alkalinity titration, suspended solid, dissolved solids gravimetry, hardness calcium magnesium also it is there. Residual sodium carbonate is more important for the, we have to calculate. Phosphate also important. If the phosphate content is there in the water column or water bodies, immediately it starts, algae is going to bloom. Then total residual chlorine for the industrial wastewater, generally for a treatment purpose, they are using a lot of chlorine. Chlorine, that's why you have to check residual chlorine by using iodometry. Fluoride, COD, BOD for the industrial effluent, you have to do it. Heavy metals, if you take any heavy metals, lead, nickel, mercury, cadmium, iron, zinc, chromium, manganese, arsenic, anything, by using atomic absorption spectrophotometer, it is a minimum tool. And high sophisticated equipment means ICP-MS, inductive coupled plasma, coupled with mass spectrophotometer, it is very good tool, ultimate tool to quantify the any metal content present in the water or wastewater in the range of milligram per liter to microgram per liter we can quantify. It is ICP-MS, little bit expensive, nearly 1 crore it is cost of the equipment. Pollution control body is having, private laboratories, they don't have this one, even AS, some labs they have. Pesticide, GCECD by FID, one technique is there, gas chromatography coupled with electron capture detector, or GCMS, gas chromatography coupled with mass spectrophotometer. It is high-end technology, ultimate technology. We can quantify more than 30 to 40 pesticides present in the surface water or lake water. Generally, borewell water pesticide is not reported so far. Some contaminated borewell may be there, but especially throughout Karnataka, if you see pesticide level in borewell, it is not reported. So up to this stage. Anyhow, but lake water and surface river water is contaminated with the pesticides. Lot of pesticides in Karnataka agriculture practice, they are using it. Importance of sampling is more important. We have studied more than 300 laboratory report we have taken it. How to accept the data? Any laboratory submitting the data means how to accept it, whether it's right or wrong. Who has to certify that one? For that one, we have to do a lot of quality control and quality assurance programs within the lab, outside the lab also. For that one, intra and inter quality assurance programs we are calling. Generally, after NABL obtaining NABL accreditation, every lab should take the NABL certificate. They have to participate in the intra and inter laboratory quality assurance programs. More than 300 reports we have taken, 300 labs we have visited, we collected South India. In Karnataka also more than 80 private labs are there, more than 100, nearly 100 government and engineering college labs are there. We have collected all the reports from all the labs. We analyze the reports. Why? How to accept the reports? What is the method we have to use to accept the report? We have worked out. And also one fine study we did, findings of the study shows that the article error is only 13% within the lab. For sample preparation, during sample preparation, 20% error it is occurring. Sample preparation means if you are analyzing heavy metals in the water or wastewater, we have to digest the sample, we have to pre-treat the sample. During that process, nearly 20% of the errors it is coming. 67% of the errors coming from the sample collection. Any laboratory is giving the report means whether that report is acceptable or not, whether we have to reject or accept, we have to check it.
Sir, take 1 minute, sir. You can take water also. So recently, that Environmental Day, we conducted a one-day workshop on sampling techniques, sir, with respect to water collection, wastewater collection, in collaboration with the Central Pollution Control Board. Because sir has given clearly the report here, 67% of errors are coming in sampling. How you are going to sample, how the samples are collected, what depth you collected, what container you collected, how you are sealed, how you are incubated, store. So all these things will error comes under 67% only. In this regard, we have released a Central Pollution Control Board has released the report. We will share all the participants later.
Yes, sir. So sample preparation itself, it is causing 20% of errors. Majority of the errors coming from the sampling because of, to be frank, qualified people are not collecting the samples, sir. This is my observation from last 40 years. Qualified person, if he collects the sample for what purpose he is collecting the sample, why he has to collect, he should understand that one. Properly, if you collect the sample, definitely out of 67% error, we can definitely minimize this error up to less than 10%. There are two types of sampling. Generally, where we have to collect the sample, how we have to collect the sample, what is the technique we have to use means, grab sample we are collecting. There are two types of sampling methods we are following in throughout India. One is grab sample. Grab samples are to be collected only when the source is known. If it is a borewell is there, if it is a river is there, we know. Every month we are collecting, we know the source. The variation of the concentration, to know that one, we have to collect the sample at a given time, given place. Given person has to collect the sample. That is called grab sample. Composite sample means, generally, if you composite sample is necessary, where every 2 hours, every 5 hours, composition of the sample is going to be changed. Example, dairy industry. Good example means pharma industries. Pollution Control Board, generally they are following composite sampling, because if you go to dairy, morning if you go to 10 o'clock, they are collecting the milk from the village, they are pouring the milk to a container. During the process, a lot of spillage of milk is there. If you go and collect the sample at the end of the outlet of the industry, definitely milk solids, fat is coming. If you collect the afternoon, the composition of the sample is different. If you collect the same dairy effluent in the evening, the composition of the wastewater is entirely different, because in the evening, they are washing the cans, they are washing the entire machinery using soaps and hot water. If you collect at 5 o'clock, 5:30, you collect the samples, your sample is containing only detergents. Lot of detergents you can see in the evening samples of dairy. That's why, in this case, we have to do the composite sampling. Every hour, a known quantity of sample we have to collect, means 100 to 200 ml every hour for 24 hours. You collect it put it in a bucket, mix it all 24 samples, thoroughly mix it and collect 2 liters out of 24 samples. 2 liters you collect, you come to the lab. That process is called composite sample. Generally, surface water we are not collecting by using composite sample. Surface water, groundwater, as well as lake, rivers, water samples we are collecting by using grab technique. For industry, we are following composite sampling technique. Groundwater. If it is well water, we have to tube well or motor driven pump or hand pump, it is there in the village side or community water supply side. We have to switch on the system, a machine, pump for 10 to 15 minutes. We have to pump the surface water in the borewell water. After 15 minutes only, we have to collect the clean container, a known quantity of sample in a clean container. You bring the sample to the, after preserving the sample in a 4-degree ice box, bring to the lab. If it is a open well, collect the sample. Only few, rarely we can see the open wells, especially in Koppal districts. You can see in Mandya districts 1 or 2 few open wells are there. How to collect the open well water samples means 30 centimeters from the surface, we have to dip the water can and fill that the height of 30 centimeters below the surface and collect 1 or 2 liters, bring properly label it and bring to the lab by keeping in the ice box. For bacteriological samples, we have to collect in a sterilized bottle. 2/3 of the 3/4 of the bottle we have to fill it. 1/3 we have to keep empty, because 2/3 1/3 why we have to keep empty means that empty place air is filled with in the empty space, it contains oxygen. The bacteria is going to utilize that oxygen to survive during the transit period. That's why you have to leave 1/3 of the bottle we have to keep empty in case of bacteriological samples. You see, this is the Kaveri River you are collecting. When you are going to the lab field, you have to go properly with the checklist you have to prepare. What are the items we require to collect the samples? Ice box we have to take, sterilized bottle we have to take, cleaned this one containers, 2 liters or 1 liter plastic or glass bottles also it is acceptable. You can go to the lab field with fully equipped kit. In the middle of the, if it is a flowing water body, Kaveri, this is the Kaveri water sampling pollution control team. You take a little bit away, about 1 bucket, filled at the center of the flowing water by using rope and bring to the lab. Here also they are doing the same way. After collection of samples, we have to preserve the samples. At least for the bacteriology and the pH, conduct a few parameters. There is a condition is there. What are the parameters we have to preserve? How we have to preserve like this? We have to preserve the sample, and as early as possible, we have to bring to the lab. You see, for pH, glass bottle you can use 100 ml. At least analyze the samples within 15 minutes. It is telling as per the records, within 15 minutes we have to analyze the pH of the sample. If we keep the sample 1 or 2 days or 1 week, due to the buffering action, pH is going to be varying. That's why field monitoring of pH is highly advisable. pH, conductivity, temperature of the water, we have to record it in the field. Then specific conductivity, within 28 days, we have to analyze it. Plastic or glass bottle, you take it, cool it at 6 degree or 4 degree temperature by keeping in ice box. TDS, total dissolved solids, same procedure, within 7 days, we have to analyze it. Turbidity, 48 hours, within 48 hours, we have to analyze it. If it is more than that one, turbidity is going to settle down along with the sedimentation process. Alkalinity, 14 days we can keep it. Hardness, 6 months we can keep it. Fluoride, 28 days. Nitrate, 48 hours. Because of nitrification process, in nitrogen cycle, if you verify that one, final oxidation product of nitrate is ammonia, it is coming out. That's why within 48 hours, we have to analyze the nitrate content in the given sample, whether it's groundwater or borewell water, surface water, lake water, any water. Sulfate, 28 days. Some people, they are collecting the sample, they are keeping 1 or 2 weeks. Afterwards, they will take for analysis. Definitely that type of reports is not at all good, because of this is the condition. Some of the parameters we have to analyze within the stipulated holding time of the sample parameters or stipulated time. We have to analyze all the parameters. Coliform and total coliform and E. coli, within 8 hours we have to bring to the lab sample. Sterilize the container we have to use. Cool the sample at 6 degree and bring to the lab within 8 hours. If you bring the sample next day, definitely it is going to die. There is no use at all. If the bacteria is present also, if you keep 1 or 2 days at ambient temperature, definitely coliform it is going to die. There is no useful purpose. All metals we can keep 6 months after pre-treatment, not directly. Before going to the sample, we have to make the checklist. Monitoring program has to be approved by the higher authorities. Higher authorities should know our staff is going to collect the sample for what purpose, where he is collecting, how he is collecting everything, and also his expenditure is involved. Any monitoring program, sampling program is involved a lot of money. That's why program has to be approved by the IR authorities. Definitely it is going to help to the staff to utilize the money for the sampling purpose. Clean container, one should have a clean container. If it is a recycled container also, we have to wash it thoroughly with soap water, followed by acid rinsing, followed by distilled water rinsing, and dry it in a oven or in a open atmosphere. You can dry it, cleaned. It should be free from dust. Such a container you have to use it. For bacterialized sample, sterilized bottle only you have to collect. Don't bring the samples in the Bisleri water bottles. Nowadays, majority 50% of the staff, those who are working in this line, I have seen, they are purchasing the Bisleri bottle, they are drinking the water afterwards, they are collecting the river water or lake water or borewell water in the same bottle. No, it is not a good practice. Bisleri bottle is not approved one to collect the water samples. Icebox one, very good icebox one, you have to provide for the sampling team. Labels, rope, one mug we have to give, marking pen we have to give, field data sheet is very, very important. What is the activities is going on surrounding the borewell or river or a tank? What is the activities going on? We have to write it in the field data sheet. If it is borewell is there, surrounding area, lot of cattle washing activities, cloth washing activities, some pits are there, stagnant water body is there, means polluted water is once again infiltrating to the borewell. That data we have to record it. And in the meantime, we can inform the higher authorities, sir, this is totally contaminated because of these activities. Definitely, we have to stop the usage of that borewell, sir. It is contaminated, fecal form, pathogens, or excess of this chloride is there, fluoride is there. It is not fit for any potable purpose, sir. We can recommend to the higher authorities to take action to supply good water in case of drinking water department. A notebook we have to provide, a vehicle has to be provided to the field sampling team. This is the checklist one should follow before going to the field. Chain of custody. This is more important. If you see, if any legal issues or anybody is challenged our data, our sampling technique, our integrity of the sampling process, if anybody challenging means, chain of custody is very important. This is essential to sample integrity from the collection to the data reporting. You have to keep every step of the records intact. This includes the ability to trace the position and handling of the sample from time of collection. After analysis, final deposition of the reports also, it comes through chain of custody. It is important to demonstrate the sample when litigation is involved. Chain of custody record has to be accompanied with sample or group of samples. Record sample number, signature of the collector, date of collection, time of collection, address of the collection, location of the collection, address of the location, sample type, whether he has collected RAP sample or composite sample, signature of the person involved in the chain of custody. All records, we have to keep it intact. Follow the procedure for all type of samples. Even labeling, sometimes they are bringing a group of samples, 10, 15 samples they are bringing, sometimes they are writing 1, 2, 3, 4. That is not the procedure. You have to write clearly sample code number, identifying location, date and time of sampling, source and nature of sample, pre-treatment, whether it is preserved or not, he has to write. And measure the temperature, electrical conductivity, pH and DO at the site itself. Definitely it is going to give good data. Otherwise, if you transport the sample from either to Bangalore or somewhere else, after 24 hours, if you analyze it, pH, conductivity, temperature, dissolved oxygen, so it is going to vary. You are not measuring actual pH of the sample. Sample analysis request sheet, one has to prepare the sample collector. The laboratory portion completed by the lab person, and field person has to complete the field procedure what he has followed. And all this record has to be maintained. One requisition letter has to submit to the lab. This is the data sheet, field data sheet, serial number of the borewell, location, date and time of collection, collected by parameters to be analyzed, field observation, human activities, cattle washing, cloth washing, polluting source if it is there, stagnant water pit is there. We have to record each and everything of the surrounding area of the water source. Definitely we can get good data. And finally, he has to submit the sample to the laboratory by writing one letter, divisional head or taluk, where we are giving. Borewell sample collected in front of the Gali Engineer temple. This is an example I have made, date and time of collection, location of sample. What are the parameters to be analyzed? Finally, along with the water sample field data sheet, we have to submit this letter to the lab to take the sample for the analysis. This is the procedure we have to follow for each and every sample. Now I am coming to the analytical portion. How to analyze the samples, how to take the samples, how to collect the samples we have completed. Trap sample I have told, composite sample I have told, even preservation timings also, sample holding timings also, it is recorded, everything it is recorded. It is in the textbook, but one should read the good analyst or field assistant has to read this thoroughly and make a note of it and so collect the sample and submit the sample to the lab. After receipt of the samples, first parameter we are checking pH. pH we have to follow IS method 3025 part 11. Very good pH meter is required. Standard buffer solutions are required. That's all. Standard procedure you have to follow. This is actually electrometric method or pH determination pH by using pH meter. Simple equipment. pH value is determined by measurement of electromotive force of a cell consisting of an electrode. pH means negative logarithm of hydrogen ion concentration. It is a little bit theory. Just it is going to give 0 to 14 scale. We have to measure it by using pH meter. What are the things are important? Just beakers, tissue paper, polythene bottle. And 3 buffers standards are required. Very good buffer standards is required to calibrate the equipment. Please don't use uncalibrated equipment. Please, you have to calibrate all the equipments. After ensuring that my meter equipment is working, then only you have to start analyzing the samples. Don't use any calibration is not done, means don't use that meter for the analysis. Take 3 buffers, 4, 7, and 10 to covering acidic range, neutral range, and as well as basic range. Calibrate the system and fill the electrode with the potassium chloride is interfilling solution. We have to check it every week. We have to check whether solution is dried or whether it is there. If it is empty, definitely we have to fill with potassium chloride. Then 3 pH buffer. Standardize the equipment for 4, 7, and 10. Calibrate the system, calculate the slope, and measure the pH. Interference generally above pH 10, high sodium concentration interfere with the measurement of pH. If the sample is containing oil and grease, if you see in industrial wastewater, they are using a lot of cutting oil, gear oil, so many oils. If the sample is containing oil and grease, don't measure the pH meter, pH of the sample by using pH meter. You can use any other method because that oil and grease, it is going to smear to the electrode surface. The next sample, if you do it, it is going to become inactive. That's why you have to treat it with acid, then ensuring that it is working properly, then only you have to use it. Temperature is also influencing the pH. If the temperature is increases, pH also it is going to be increased. When you are starting the equipment, please switch off the equipment, half an hour, leave it. Don't disturb it. It has to be stabilized. Calibrate the instrument by use of 3 buffers, 4, 7, and 10. Electrode may be immersed directly from the beaker having a sample. Stir constant rate to provide the homogeneity and suspension of solids. Record the pH. Only after the point 2 decimals, please report 2 decimal only. Some people they are reporting 7.002, 7.112 like this. Don't report that one. Either you use it 1 decimal after the point or maximum allowed is 2 decimal. Then coming to this conductivity. Conductivity is more important for the surface water as groundwater or borewell water, any water except wastewater. Generally, waste conductivity in the organic water containing organic waste, we are not measuring because organic molecules, organic ions are not sometimes non-conductive. That's why only surface water, groundwater, we have to do the conductivity measurement by using IS 3025 part 14. Books are available freely from the institution. You log into the IS website. You can download free of cost now. Previously, it was highly expensive, 200 rupees, 300 rupees, 150. Like they used to charge, now they have made it free. You collect, download the procedure, store it in your lab. If any changes are there, any additional information is there, they are going to release one more part. Then you collect it and file it. Method, please see this method IS 3025 part 14. Please use this method. Don't use old methods. Some theory. Generally, temperature also affects the conductivity. Samples having fat, grease, oil may contaminate the electrodes, causing erratic results. If the sample is containing oil and grease, don't measure the conductivity of the sample because your electrode is going to be spoiled. White, colorless fat is going to smear to the electrode body, it becomes inactive. If you measure the inactive using inactive electrode, your data is wrong. That's why you have to see the samples physically, whether the sample is measurable or not, whether it is containing oil and grease. Separate the oil and grease, fat, anything. Then supernatant liquid you can use to measure the pH and conductivity. Here also there is simple conductivity cell. We have to standardize the cell by using KCl solution. 0.01 KCl solution, it is going to give you 0.01 molar KCl solution is standard solution. You have to use NIST, this standard or IR certified standard, we have to use it. 0.01 molar KCl solution is going to give you 1413 microsiemens per centimeter. This is standard. If we take this standard, measure the conductivity, set the instrument for 0.01 molar KCl solution at 1413 microsiemens per centimeter, fix the slope and fix the values at 1413. Then keep it in memory. Then you take 100 ml samples. Completely, you measure it as per the procedure, follow the IS code. It is simple. Note down the reading. There is simple meter. This is not a complicated meter. Only thing, ensure that your meter should give for 0.01 molar KCl 1413 microsiemens conductivity. This is standard one. To check the instrument working or not also, we are using 0.01 molar KCl. Certified one, please use certified one. Turbidity, it is a simple equipment. Tyndall effect or scattering phenomena. Simple, just 12,000 rupees, 13,000 rupees equipment. It is going to give a lot of information about the turbidity of the sample. Based on the comparison of intensity of light scattered by the sample under the defined condition with the intensity of light scattered by a standard reference suspension. This is standard reference suspension. This is sample. So, interference colored solutes. Colored samples definitely cause a lot of turbidity interference. It is coming. We have to check, we have to physically verify the samples whether it is colorless or color. And also accordingly, we have to do the correction also. A lot of correction factor is there. The instrument called turbidity meter and effluent both are same. The turbidity should be designed that little stray light reaches the detector and in the absence of turbidity and should be free from significant drift after the short warm-up time. This is the one condition we have to verify. Reagents means one turbidity standard is coming. It is a mixture of two. Hexaethylenamine tetramine solution A, hydrogen sulfate solution B, suspension A and B, mix it thoroughly. And next day, after 24 hours only, you have to use the standards. If today you are preparing the standard, means today don't use that one. It is not completely become suspension. It requires time 12 hours to 14 hours, 24 hours. After 24 hours, mix the equal quantity as per the recommended volume. Mix it and it is going to form a turbidity suspension. The turbidity calibration by 10 NTU also we can do, 40 NTU also we can do, 100 NTU. Normal turbidity unit, Neflo turbidity units we are calling. We can standardize the equipment generally minimum 40 units, 0 to 40 units you are calibrating. And also you can 0 to 100 NTU, you can calibrate the system by using standard turbidity solution. Calibrate the system after calibration, use the sample. Just it is simple, fill this vial, insert in this one. It is going to give you the turbidity value. If it is a dilution factor is there, dilute reading into dilute the dilution factor. Color also very important. If colorless water is not at all available, even if you take borewell water, it is gray in color, sometimes yellow in color. It filled with a lot of mixed substances. So color is important parameters we have to measure. It is the expensive technique. Color, because we have to read the color in chloroplatinate scale. Platinate, cobaltous chloride and platinum chloride both are expensive. 1 gram each is costing more than 24,000, 24,000, 45,000 per set of standard it is required. For 2 months, we required at least 70 to 80,000 rupees for the color standards. Generally, that's why people are not at all measuring. They are by naked eye, what they are seeing, they are writing it. We have to measure it. What is the color, intensity of the color, we have to record it. Generally, chloroplatinum scale, visual color comparison method we are using, or also we can use by using spectrophotometer reading also we can take. Color is measured by visual comparison of sample with platinum chloride standard. 1 unit of color is produced by 1 milligram platinum per liter of chloroplatinate iron. It means that 1 ml is equal to 1 milligram of platinum you are taking. That is going to give you 1 color unit. Because of expensive, people are not at all using. Some people they are using it. NaBl, it is a mandatory, they have to use it. Prepare series of chloroplatinum solution liquid is a series of standard. And the intensity of the color you record it. And also we can see like this color comparison method. Standard you take it, one side you put samples, read the see the color by intensity of the color by comparison the color with the standard. This is called color comparison method we are calling. If the color is 1 to 50 units means nearest record to nearest value means 1 color unit. This is 51 to 100 means 5. There it is summarized as 5 color units means in the chloroplatinate scale. 101 to 250 means 10 color units. 251 to 500 means 20 color units in the chloroplatinate scale. Generally, by visual comparison method, we are following. Odor, there is no meter at all. Afflectometer is there. Afflectometer electronic was 2 devices are available, but both the device gives odor reading. For bad smell also it is giving reading. For good smell also it is giving reading. Which is bad smell, which is good smell, it is not at all recognizing it. That's why we are not using any meter for the color odor measurement. Our nose only the meter. What is the smell it is coming, we are writing directly. Color odor of the sample is pungent, acidic, rotonic, severe smell like this. Good smell like fruity smell, flower smell, it is not, it is giving same values like bad smell. Bad smell. If you open the ammonia bottle, read the record. If it is giving 150 color odor unit means it is pungent. You cannot stand there. It is same. It is also giving 150 for the good dose. Flower smell also it is giving 150. The meter is not able to recognize whether it is a bad smell or a good smell, but smell it is odor it is measuring. It is bad or good. That's why generally we are not at all measuring. Just by our nose is the meter. by smelling it indirectly. You have to indirectly smell it. Directly, it is not allowed to smell. If you smell directly ammonia, definitely burning sensation in the nose, blood is coming out. That's why indirect smelling, followed by, we can write pungent smell, acidic smell, rotonic smell, severe smell, like that. 4, 5 smell, we are writing it. The quantity of the smell, we are not at all measuring it. Fluoride, very important one. IS 3025 part 60. This is IS code. We have to follow. As per the NABL recommendation, this is a very good method. Procedure fluoride applicable for the determination fluoride in water and wastewater. Both water, it is applicable this method. One good spectrophotometer is required. The color obtained with zirconium alizarin reagent is matched with against the produced with a series of standard fluoride solution. Spans method is a good method. This method is suitable for estimation of fluoride up to 1 milligram. More than 1 milligram also we can see, we can measure by using this method. Interference in all the methods is there. Interference, iron, alkalinity, phosphate is interfering. We have to eliminate it. And interference, free residual chlorine also it is going to interfere. That's why free residual chlorine, if it is there, we have to kill it by adding sodium thiosulfate. Alizarin, zirconium alizarin reagent, it is as per the procedure, you have to weigh known quantity of the zirconium oxychloride, 0.25 gram of zirconium oxynitrate in distilled water and mix it to two solutions. It is going to give very good color. That color intensity, if it is fluoride is going to react with spand reagent. That reaction we are calling as a bleaching reagent, bleaching reaction we are calling. The intensity of the dye, it is going to decrease with increase of fluoride content in the water. This is the principle we are applying to determine the fluoride content. We are taking sample of 50 ml or 100 ml series of sample you take, add 5 ml of the reagent, spand reagent. If the fluoride content is increasing, intensity of the color is decreasing. That is the principle. Generally, we used to take NIST standard as a fluoride standard for the standardization process. After standardization, measure the fluoride content in the given water samples and plot a curve. Like this, we have to plot this curve. Concentration versus absorption by using spectrophotometer, we have to plot this curve and calculate the curve, calculate the slope, use the slope for the calculation of the fluoride. Fluoride milligram per liter is equal to reading into calibration factor into 1000 divided by ml of sample taken. This is the equation you have to use it to estimate the fluoride content in the bore well or river water or lake water or wastewater. Same method we can use it. Hard test calcium magnesium. IS part 3025 part 21 we have to use it. This is specific standardized procedure. Same method you have to follow. Method is EDTA titration method. Temporary hardness, magnesium hardness. Principal water sample is buffered at pH 10 and taken into a conical flask. An indicator dye of erythrome black tea indicator when added to a solution containing calcium, magnesium, iron, the color of the solution turns into wine red. Wine red, EDTA, the titrant complex with magnesium and calcium ions, removing them from the association with the indicator. When all the magnesium, calcium are complex with EDTA, the indicator will turn blue. This is the equation. This is the titration method. We have to use EDTA titration, easiest method. Take 50 or 100 ml sample in a conical flask, add 2 ml of ammonia buffer to increase the pH to 10. Add pinch of erythrome black tea indicator, titrate against EDTA solution. The end point is pink to blue. This is the very simple throughout the world, same procedure we are using it. EDTA titration method is simple method. We can do 100 or 200 samples per person per day. Calcium, magnesium also we can measure by using AS or other methods. It is expensive. Good simple method, less cost, very good accuracy. We are getting it by using this EDTA method. You can use it. Total hardness is equal to titer value into normality of EDTA into 1000 into 100 calcium carbonate molecular weight into 1000 milligram per liter. We have to calculate volume of the sample taken. Volume of sample taken for titration. This is the equation you have to use it. Determination of calcium hardness, same method, EDTA titration method, 3025 part 40, you have to use it. Please follow same methods for the calcium, magnesium, both. Calcium and total hardness. Magnesium is difference calculation method. EDTA 0.01 molar sodium hydroxide reagent is required. Pattern and reader indicator for calcium. As a calcium standard, we are using NIST calcium carbonate as a standard. Take suitable portion of sample in a conical flask means you take 100 ml or 50 ml, add 1 ml of sodium hydroxide, pinch of pattern and reader indicator, titrate against standard EDTA. Endpoint is wine red to blue color. This is the endpoint easily. Calcium hardness is titer value into normality of EDTA 100 calcium carbonate molecular weight to 1000 divided by ml of sample taken. Simple titration methods. It is not so tedious, so scientific, so lot of highly sophisticated instrument is not at all required. Just one burette, conical flask, good reagents are required. Standard chemicals are required. Easily we can do calcium, total hardness, calcium hardness, magnesium also. For magnesium, this is the equation you have to use. Magnesium as milligram per liter is equal to total hardness minus calcium hardness minus total hardness minus calcium hardness is equal to magnesium hardness. If you want magnesium as Mg multiplied by 0.243, or if you don't want as a magnesium, we want as magnesium carbonate means total hardness minus calcium hardness. Simple. Chloride. Chloride is the important parameter. Please follow IS 3025 part 32. Standard, this one IS standard is freely available. You can download it. Argentometry titration method. This is called argentometry. We are calling simple throughout the world. We are using it. If the groundwater, surface water, chloride estimation, argentometric is very good. For a colored sample, we have to use different method. Colored sample, industrial effluent. If you take sugar industry or distillery industrial waste, it is always dark brown color. Endpoint identification is difficult to estimation of chloride. In that case, we have to use potentiometric titration, other methods. For the groundwater, surface water, lake water, argentometric titration method is very good method. Reagents are potassium chromate, standard silver rated. Only 2 chemicals are required. Take 100 ml of sample in a conical flask. If the sample is highly colored, add aluminum hydroxide suspension. Mix it, let it settle and filter it. Directly titrate a sample at pH 7 to 10. Adjust the sample if pH 7 to 10 by using sulfuric acid, sodium hydroxide. If the acidic sample or basic sample is there, you have to neutralize the sample by using acid or alkali. Add 1 ml potassium dichromate potassium chromate indicator. Treated with standard silver rated solution. Yellow to brick red color is the endpoint. This is the simple silver reacts with chloride is equal to silver chloride is a final product. After complete exhaust of chloride, silver is going to start reacting with chromate ion. It is forming a brick red color. That is an endpoint. This is the calculation we have to use. V1 minus V2 into normality of silver nitrate into 35.45 is the molecular weight of chloride. 1000 divided by ml of sample taken. Those who are doing research in this water analysis, please use this method, which is the same equation. Sulfate also very important parameter in the water. Sulfate, you can use APHA method, or 4 methods are available. Sulfate, first method is condition reagent method, nephelometric method, APHA method. 4 method is there. Out of 4 methods, easy method means nephelometric method is very good. Take suitable amount of sample in a conical flask or Nastler tube. Add condition reagent 5 ml or buffer solution, required quantity 20 ml of buffer solution. Read the absorbance after 5 minutes by using spectrophotometer 420 nanometer. This one also we can do. By using nepheloturbidity meter also we can do. Both the methods are simple to estimate the sulfate. As per the IS method, recommended method, spectrophotometric method is good and also recommended, you can use it. After adding barium chloride, sulfate is going to precipitate barium chloride suspension. We have to read the suspension intensity by using spectrophotometer at 420 nanometer wavelength. Plot the curve, standard versus concentration of the sulfate versus absorption. Read the sulfate concentration directly from the calibration curve. Simple, this is not a big. Sulfate milligram per liter is milligram of sulfate present in the sample into 1000 divided by ml of sample taken. Is simple. Equation to calculate the sulfate, you can use it. Alkalinity also very important. If the alkalinity is very high, the sample, the water becomes corrosive. So alkalinity, to determine the alkalinity in the given water samples, use IS 3025 part 23. Please use this method. IS 3025 part 23. This is some series there. Take 50 ml sample in 250 ml class. If the pH of the sample is more than 8.3, add 2 to 3 drops of phenolphthalein indicator and titrate with standard sulfuric acid. The solution till the pink color absorbed by the indicator just disappears. Record the standard sulfuric acid volume used. It is phenolphthalein alkalinity. To the same sample, add 2 to 3 drops of methyl orange indicator. Continue the titration up to the end point. Again, it is the orange to dark orange color, it is appears. Use this equation, phenolphthalein alkalinity, A into N into 50,000, we have made it. Methyl orange alkalinity, A plus B into normality into 50,000 divided by ml of sample taken. A means ml of sulfuric acid used for the titration up to pH at pH 8.3. P is the standard sulfuric acid used for the titrate of 8.3 to 3.7. Normality of the sulfuric acid. Volume of the sample taken in the conical flask. These two equations you have to use it to calculate the phenolphthalein alkalinity or methyl alkalinity or total alkalinity. Nitrate also important parameter in the drinking water or borewell water. Nitrate we have to use IS 3025 part 34, 1988. It is published in 1988. Good method. This method is applicable to estimate the nitrate content in borewell, surface water, lake water, river water, and also industrial effluent. Also, we can use industrial estimation of nitrate in the industrial effluent. This method is also applicable. 2 moles of nitrate nitrogen reacts with 1 mole of chromatropic acid. Chromatropic acid method, simple method, to form a yellow reaction product having maximum absorption at 410 nanometer. By using spectrophotometer at the wavelength 410 nanometer, we have to measure the intensity of the yellow color. This is simple but time-consuming process. This is theory, 2 moles. Residual chlorine, certain oxidants is interfering. Urea converts nitrate into nitrogen gas. The maximum detectable quantity of 50 microgram of nitrogen per liter. Spectrophotometer is required. 410 nanometer wavelength. Path length of 1 centimeter long cuvette is required. Stack 1000 ppm of nitrate standard you can use. It is available 1000 ppm ready made, or you can prepare in your laboratory by using good quality of chemicals. You have to prepare a series of antimony reagent, chromatropic acid reagent as per the calculated recommended quantity of the chemicals. We have to weigh, we have to dissolve in known quantity, keep it as a reagent, and prepare a series of standards, 0.1 milligram to 5 milligram per liter by diluting different volumes of standard. Prepare 2 ml portion of standard nitrate solution, sample and water blank. Blank also you have to run simultaneously. Each flask add 1 ml of sulfite urea reagent, place in the tray. Cold water we have to, temperature we have to maintain at less than 20 degrees. 2 drops of antimony reagent we have to add. Fill the flask. During the addition each reagent we have to shake the flask to react faster. After 4 minutes, 1 ml of chromatropic acid you add it. Cool in the cooling bath for 3 minutes. Add concentrated sulfuric acid to bring the volume to the 10 ml. So it is going to give a color. The color intensity we have to measure it 410 nanometer between 15 minutes and after, before 15 minutes. Use nitrate-free water for the as a reference. Plot the curve absorbance versus concentration of nitrate. This is the curve, nitrate curve. We are getting it like this. This is the equation you have to use to quantify the nitrate content in the water. Reading into calibration factor into 1000 divided by ml of sample taken. This is the equation you have to use it for the calculation purpose. Dissolved solids, there is Diametric Method. The sample is filtered and filtrate evaporated in a pre-weighed dish on a water bath. The residue after evaporation are dried at constant mass at 103 to 105 degree temperature. Keep it in a desiccator and then weigh it. It is a 2 grams. Do gravimetry. Initial weight minus final weight of between 100 ml of sample or known volume of sample. One water bath is required. Evaporating discharge is required. Oven is required. Desiccator is required. Balance is required. 4-5 equipments are required. Simple test. Heat the evaporating dish at 105. Generally, for the evaporation at 105, we have to keep. Filter the known volume of sample through water number 41. We have to use it. 41. Please remember this one. 41 filter paper. We have to use it for the dissolved solids. People filtered sample into a pre-weighed dish. Initially, we have to take the empty dish weight and pour known volume of the sample, evaporate it in the water bath. After completion of the evaporation, keep it in the hot air oven, then desiccated, then weigh it. 2 grams. TDS is equal to 1000 into M divided by V. M is equal to W2 minus W1. This is the equation. We have to use it to estimate the dissolved solids in the water. Determination of iron. One thing we can analyze the iron or any heavy metal by using AS. If AS is not available, you can use it. This one use 110 Phenothrin method means IS 3025 part 53. Please record this one methods. IS method, as per the IS method, you have to do the experiment. The name of this procedure is 110 Phenothrin method. It is also simple. Iron in solution is reduced to ferrous state by boiling with hydrochloric acid and hydroxyamine and treat with 110 phenolphthalein at pH 3.3. 3 moles of phenolphthalein chelate each ions of iron, ferrous iron, to form an orange-red complex. The color intensity is dependent on the pH. A pH between 2.9 to 3.5 ensures rapid color development in the presence of excess of phenolphthalein. This method is applicable to 75 to 500 microgram per liter of iron present in the water samples. This method is applicable to water, groundwater, surface water, both, as well as industrial effluent. Also, we can use the same method. Reagents. HCl is required, hydroxylamine is required, ammonia acetate buffer is required, stock iron solution, sodium acetate solution, 100 ppm, 1000 ppm of this standard we required. Pipette out approximate portion of standard iron solution from 10 to 150 microgram per liter of iron. Dilute the content of each conical flask to 50 ml by adding water. 1 ml hydroxylamine solution, 2 ml of concentrated HCl, add boiling chips. Boil it for a few minutes. The volume should reduce to 20 ml. Cool to the room temperature quantity, transfer to 100 ml water polymeter flask. Add 10 ml of ammonium acetate buffer. 10 ml of 110 phenolphthalein solution each flask. Dilute to 100 ml with water. Mix it. Stand for 10 to 15 minutes. After 10 to 15 minutes, measure the absorbance of iron complex at 510 nanometer. Construct the calibration curve plotting absorbance versus concentration of iron. Take 50 ml sample, 1 ml hydroxylamine solution, add it, 2 ml HCl. Follow the same procedure. Plot the curve. Absorption versus concentration of the iron content. This is the curve. For unknown sample, measure the intensity of the color and calculate the color. Calculate the iron content. Microgram of iron into calibration factor into 1000 divided by ml of sample taken for the color development. This is the iron calculation. Please refer this equation calculation for the. Please use this calculation for the calculation of iron content in the water sample. Cyanide, generally industrial effluent, generally we are asking to analyze the cyanide. There are two types of cyanide. One is free cyanide as HCl, another complex cyanide has a complex. Ferrous ammonium sulfate, like this complex is there. For that one, different procedures we have to use it. BOD, COD, also same thing. BOD is generally we are asking in industrial wastewater, as well as sometimes borewell water, generally BOD is not coming. COD it is coming. If it is contaminated borewell means BOD they are asking. But in lakes and rivers we have to do the BOD, COD both. This is simple indirect method. Biochemical oxygen demand. Biologically we are biologically estimating by adding chemicals, estimating the difference between the DO in the first day to third day. It is called biochemical oxygen demand reaction. Generally, 300 ml BOD bottles are required. We have to calculate how sample is required, what is the level of DO first day, how much it is there. After 3 days, what is the DO? It's decreased in the bottle after adding bacteria. We have to see. I will tell you reagents. These are the buffers we have to prepare. This is lengthy, time-consuming process. BOD. As per the direction, we have to prepare the sample. We have to prepare the all buffer solutions as a food to the bacteria. Dilution water. Generally, what we have to do, if a given sample, first we have to do the pH, COD. After knowing the pH and COD, BOD experiment we have to start. What would be the BOD? If it is sewage, if it treated sewage means Untreated sewage means 60 to 70% of BOD to the COD value. Treated 20 to 30%. Like this, we have to expect the BOD values in the treated and untreated wastewaters. Food industrial wastewater 70 to 80% untreated. Treated 10 to 25%. Pharma industry 60 to 70%, 30 to 40% treated. Paper and pulp, it is not so easily degradable. We have to add extra bacteria to degrade. Agro-industrial waste, untreated means 50 to 60% of BOD to the COD value. If it is 100 is there COD, 60% means 60 milligram per liter is the BOD. Generally, COD, BOD, really it is a good parameters to estimate the organic load present in the wastewater. Chemical oxygen demand is determined by the oxygen requirement of equivalent of oxygen organic matter that is susceptible to the oxidation with the help of strong oxidizing agent. This is theory, theory is coming. This is the chemical reaction. We are taking dichromate solution in acid. We are adding samples known quantity. Then now we have to boil it at 105 degree, 150 degree for 2 hours. All organic matter is oxidizing. Then this is the chemical reaction involved in the oxidation process. Operators are required to 250 ml conical flask, reflection condition, COD digestion, apparatus, volumetric pipettes, burettes, all are required. Take 5 ml of procedure. I will come directly to the procedure. Take 5 ml of dichromate solution, 15 ml of sulfuric acid, plus add 10 ml of sample to the flask, and 0.4 grams of mercury sulfate and silver sulfate we have to add. Mercury sulfate we have to add to remove the chloride. Silver sulfate as a catalyst we have to add. So reflex it on the aluminum reflexing chamber. Then after 2 hours reflection, all organic matter is digesting. Then remove the reflection flask and cool to the room temperature and titrate against ferrous ammonium sulfate. Standard ferrous ammonium sulfate as a ferrine indicator. Note on the burette reading. COD milligram per liter is equal to A minus B into normality of the ferrous ammonium sulfate into 8 into the molecular equivalent weight of oxygen into 1000 per ml of sample taken. This is the equation we have to use to quantify the COD. After measuring the pollutant level by using IS method, any other method in water or wastewater, generally groundwater or surface water, if it is being the sample is using for the drinking water, the reports is comparing with IS standard. This IS 10,500 2012 standard, the colors, everything required acceptable limit and permissible limit, both limit is there. We are comparing the water quality with for the drinking purpose with the IS standard. Whether it is exceeding the IS standard or within the IS standard, if it is within the IS standard, water quality is good. If it is exceeding, it is not conforming to the standard. Like that, we used to generate the report after analyzing by using specific IS standard. IS procedures. For drinking purpose only, we are comparing the result report with the IS standard. Drinking water specification. All the parameters they are given. Color, what is the color, pH, taste, color, odor, turbidity, dissolved solids. Generally, 500 is the acceptable limit, TDS value. For permissibly 200 milligram per liter also it is allowed. For the drinking purpose, where there is no alternative sources are not available. If you come to Tumkuru, Chitradurga and Ballari, such areas, always borewell water is always more than 1000 milligram per liter of TDS. There is no alternative source. There is no rivers and lakes. People say they are using it, the same water. Nothing is happening. Up to 200 milligram per liter of TDS, we can drink it. Generally, we used to drink 5 liters of water, 4 liter. into 500 milligram into 4 liter is equal to 2 gram of salt is required for the good water. And we are giving the reports based on by comparing the data with the highest drinking water standard, whether it's fit for drinking or not fit for drinking. And remaining surface water bodies, lake or rivers, if it is there, CP, Government of India has classified the surface water bodies into 5 categories. One is Class A, Class B, Class C, Class D, Class E. Class A means drinking water source without any conventional treatment. Directly drinking water source not at all available throughout India. If you go Brahmaputra also, it is contaminated with fecal form. Drinking water source without any conventional treatment means directly we cannot drink anywhere in Indian this one, any state. For outdoor bathing, quality of the standard is Class B. The coliform is allowed to 500, pH 6.5 to 8.5, dissolved oxygen 5 milligram per liter or more. Drinking water source with after conventional treatment, we are calling as a Class C. Water quality best Class A. Coliform is 5,000 milligram per liter. We have to treat it. After disinfection, we have to drink it. pH is 6 to 9. DO is 4 milligram per liter or more. BOD is 3 milligram per liter. This type of water quality we are calling as a Class C. This Class C water without treatment, we are not supposed to drink it. After treatment and disinfection, we can drink it. No issue at all. Class D means the pH is 6.5 to 8.5, DO 4, ammonia 1.2 milligram per liter or less. This type of water we are calling as a Class D. This quality of water we are using for the propagation of wildlife, aquaculture, the fisheries. Class E, irrigation, industrial cooling, controlled waste disposal. There they have introduced electrical conductivity, sodium absorption ratio. Boron also they have introduced in case of this one. You analyze the sample, you find out the boron, sodium absorption ratio, electrical conductivity. If it is more than this value, we are classifying as this water belongs to Class E. This water may be used for the irrigation, not for the drinking water, propagation of wildlife. But it is not fit for anything, only for the drinking or irrigation and industrial cooling, we can use it. This is classification criteria throughout India. We are following the same procedure to classify the surface water bodies. Lakes and rivers, we are using this classification to classify this one. In Karnataka, maximum rivers and lakes are lies between C class 80% and 20% D class. D is propagation of wildlife. It is not fit for drinking also. Without treatment and disinfection, nowhere in Karnataka, C grade water is not A grade or B grade, not at all available. All our available water is C grade. Borewell, only borewell, we are comparing with the highest standard. Remaining lakes and reservoirs and rivers, we are comparing with CPCB classification and Government of India classification. This is the only classification criteria to classify the surface water. The surface water is having which grade we can classify as a grade water or B grade water or C grade water, D and E. This is for the general standard for the industrial discharges. For the industries only this standard is applicable, not for that for a borewell water highest standard only we are following. For lakes and reservoirs, we are following CPCB classified designated best use criteria of A to E grade we are following. For industrial waste, we are following general discharge standards as per the Environment EP Act 1980, EP rule 1989, we are following. The industries which is discharging the wastewater into inland surface water, they have to follow these inland surface water parameters. If the industry is discharging the public sewers, they have to follow these parameters. If the industry is discharging land for irrigation, they have to follow these parameters. The industry is discharging the waste into the marine and coastal area, they have to follow these parameters. Finally, for inland water surface, 33 parameters we have to analyze. For public sewers, 22 parameters. Land for irrigation, 8 parameters. Important 8 parameters we have to analyze. Marine, 29 parameters as per EPE rules 1989. For the industries, it is not applicable for the surface water or groundwater. And one more interesting relation is there. Always COD is greater than BOD and TOC in case of wastewater. In case of borewell water or surface water, total coliform is always greater than fecal coliform. Majority of the labs, they are reporting ulta. Total coliform always in general, it is more than fecal coliform. Total solids is always greater than TDS, total dissolved solids. Total solids greater than TSS, total suspended solids and total dissolved solids. Total suspended solids and total dissolved solids, add it, we are going to get total solids. And theoretically also we can calculate the total dissolved solids, 0.6 into alkalinity, plus add all the ions, chloride, sulfate, nitrate, fluoride, phosphate, sodium, potassium, calcium. The summation of all the ions should be less than TDS value. This is one of the criteria we are following to verify the reports. For a given sample, measure the conductivity, multiplied by 0.67, approximately equal to 98% of the TDS. This is also one of the thumb rule we are following to verify the data. One more thumb rule, acceptance criteria of any report is equal to summation of all the ions should be less than 0.95 to 1.05% of TDS value. This is a second acceptance criteria for any given reports we are following. Add all the ions, that is called TDS. The acceptance criteria, all the summation of all the ions should be less than TDS. How much less than means 0.95, 95% to 105%. 5% error is allowing in this criteria. If the pH is less than 6, sulfide will not be present. Sometimes people are reporting sulfide also at pH 8. It is wrong. If the less than 6, sulfide will not be present. If the pH is less than greater than 8, ammonia will not be present. If the pH greater than 8.3, total alkalinity is always greater than hardness. If the pH less than 8.3, total hardness is always greater than total alkalinity. This is the sum of the thumb rule criteria we have to follow during accepting the reports. Conductivity, you have to report as millisiemens, microsiemens per centimeter only. Some people they are reporting millisiemens, so in different way. But as per the enable direction, we have to report microsiemens per centimeter. This is more important criteria to accept the reports or reject the reports. One water samples I am taking, I am verifying all the things. Already I explained. In a given water, we are classifying into major ions and minor ions. Under major ions, major cations and major anions we are classifying once again. The concentration in the range of 1 to 1000 milligram per liter. What are the elements comes under major ions with calcium, magnesium, sodium, potassium, iron, silica, aluminum, chloride, sulfate in anions. Use this equation. Acceptance criteria is equal to summation of all the ions is equal to 95% to 105% to the TDS value. If it is there, the report is acceptable. Otherwise, no. Compute ion sum. There are 4 manuals. They are given different. This one I have taken all the equations to verify the reports. Compute ion sum. Hydrology department, they have released one equation to accept the reports or reject the reports. The summation, add all the ions, cations, convert into milliequivalents. Plus add all the anions, the summation convert into milliequivalents. The ratio of cations and anions should be 1. This is one more criteria. 3 criteria we are using to verify the lab reports, whether it is acceptable or rejectable. This is more important slide. Please refer this equation. In any reports when you are receiving for your purpose, please follow this equation and verify the reports. One or two few examples I am showing. This is one of the famous laboratory analyzed in Bangalore. The report is whether the borewell is required RO or not. For that purpose, they have analyzed the collected the samples and they have analyzed the report. This is very good report. They have, as per the NABL, it is NABL accredited, NABL approved lab is there. They are followed the very good methods. But you see the verify the reports. Turbidity less than 1, pH 7.94, it's fine. TDS 404, fine. Hardness is there, calcium is there, everything it is there. Whether this type of report can we accept or reject? This is the question. How to verify this report, right or wrong? This is more important. Simple, this one. TDS, I have already explained 3 equations I have given. One is summation of all the ions. That one also you can use it, less than TDS. Now TDS is 404. Total hardness is 350. Chloride 169. 350, 169. Add it, it is more than TDS. Hence, the report is not acceptable. It is a rejectable report. Let's see this report. 47% error. If you verify the data, if you verify the method, it is NABL accredited lab, it is a well approved methodology, they have used it. Results also, format is same, interpretation also same, very good. But if you verify the report in terms of ion to ion relation, the summation of TDS, if you use 2 thumb rule, the report is not acceptable because error of 47%. All the summation of all the ions more than TDS, it is wrong. Somewhere chloride may be wrong, or hardness may be wrong, sulfate may be wrong. This is the decision we can take it. Then second report, this is a treated water. TDS is 50, hardness is 50. How can you accept this report? Total dissolved solids is 50, only hardness component is 50. It is NABL. It is approved method, APHA. Well documented method, well established lab, very good report they have given. Format is right. You see, required acceptable limit, all limits he has given. But as per this one, thumb rule, it is not at all acceptable because dissolved solids is 50, hardness is 50. If you take remaining ions, it is exceeding the TDS value. That's why it is not at all acceptable. Error of 64% because of all the ions is more than TDS values. One more report is there. No, important. This is the. Please refer this report. TDS is 36. Hardness is less than 10. Calcium is less than 10. Magnesium is less than 10. Chloride is less than 10. Is it acceptable report? Is it straight away rejectable report? Because people are reporting like this. This is safe way to report the bad reports. Safe way. They are following the correct method. It is NABL chemical testing, water testing approved lab. Data you see. Safer way. Nobody can question because less than 10. You don't know the detection limit of that method. That's why the report is highly wrong, highly rejectable because of the range of testing and detection limit is not known. The reported detection limits are 10 and 5, they are reported. But detection is 1 milligram per liter. Simply hardness 1 milligram per liter also we can detect. Yes, safely has reported 10, 10, 10. Not at all acceptable. Thank you, sir.
Sir, thank you, sir. You have shared a very detailed report with respect to water and wastewater analysis. See, today all the engineers has to take some information from this today's talk. See, actually the testing of water is important, and also how they tested. Sir has given in detail what are the IS code procedures you should follow to test the water. When you are accepting the water, you should know all these thumb rules given by the Nagappa sir, because experience speaks. Sir, I have only one question for you.
Sir.
You mentioned all these thumb rules, whether it may be based on experience or any.
No, sir, it is well documented. Well documented.
Okay. It can be accepted throughout the globe.
It is accepted. Legally, it is accepted.
Yeah. See,
It is
actually,
sir, one source is hydrology department. They have published a book.
Okay.
In that one, total compute, ion compute method is given.
Yes, sir.
NEERI is there. NEERI has published the manual.
Okay.
NEERI, they have TDS is nearly 98% of conductivity multiplied by 0.67 is equal to 97%, 98% TDS equation they have given.
Okay.
NEERI also reputed institution, National Institute, that is also acceptable.
Okay, sir. See, actually, as a construction engineers, you have to take care of what is the chlorides and sulfates availability, because chemical deterioration of concrete. Concrete is going to distress if the sulfates and chlorides are more than permissible limits. So I request all the engineers to go through IS 456-2000. They're given what is the permissible limits. If the limits are exceeds, what is the solution? Then for every problem, there is a solution. Therefore, you have to use a different types of cements and also the reduce in water cement ratio, use of mineral admixture and chemical admixtures. So actually, this is a very highly informative. It is a, sir has refreshed all the test aspects and what is the procedural aspect. As a civil engineer or a construction engineer, you must have basic knowledge of all testing procedures, and also where you have to give the sample, how the report should be accepted. You must have aware of all these things as the in charge of the site, because simply you cannot accept and finally you should not blame them all these things. Well, thank you very much, sir, for your sparing time and accept your invitation and giving in-depth information with respect to testing procedures, collection of samples and testing procedure of the samples, and also how to check the genuinity of the report. Thank you once again for your valuable information, sir. And also I request the participants, if you have any queries, please talk to the speaker.
Sir, any questions, sir?
Any questions from the audience?
Regarding water chemistry, water analysis report.
Vidyashri MG? Vidyashri? Vidyashri is available? Sanat?
No, sir.
Huh?
No, sir.
Yeah, okay. I think I saw she has participated on
I was
LinkedIn.
there after the presentation, but
Okay. And any other questions from anybody?
No questions. Thank you very much, sir. You have given me a good opportunity to talk to civil
I should say
engineers.
thank you, sir, for your spending your time with us, and definitely we will have an offline class also. And also we wish to see some laboratories, sir, which in a way you can suggest us, because we have to make one-day trip for all Nirmitic engineers. Any good lab in Bangalore?
Yes, sir. Definitely, sir. Definitely, I will
We
make
recently
it.
visited Eco Green Solutions. There,
Okay.
the students saw many equipments. It is also enable accredited lab.
Sir, NABL accredited, also recognized under Environment Protection Act.
And we wish to see one municipal waste management techniques with recycle reuse. Whether we will suggest Carbon Park or which is the best municipal waste management.
Carbon Park also okay, sir.
Oh, thank you, sir. Thank you.
Carbon Park also okay.
Yeah. I request
Thank
all
you
the
very much, sir.
Huh?
You have given a good opportunity to address the civil engineers. Really, I am
Thank you,
happy.
sir. Thank you, sir. And also, I request the participants to give our feedback. Feedback forms are posted by Mr. Sanat Kumar for the certification and also for other things, attendance purpose. If no questions, we can close the session. And also, I'll thank all the participants for active participation. And also, I'll thank Sanat Kumar and other faculty members of NCET for supporting making successful event of this seminar. Thank you once again to all of you.
Thank you, sir.
Thank you.